Right, now here we are on the second page with some important ideas. The definition of trig identities. So this first definition here is what an identity is. It's a mathematical statement that is true for all values of a given variable. So unlike, let's say when we do traditional algebra, and if I said, I don't know, 3x plus 1 is equal to 7, you could find out for what values of x is that true. Okay, now in this case, I guess it's only true when x is equal to 2, so that's when we solve, right? But what if we had a statement like 1 times n is equal to n? This is an identity because it's true for all values of n. So no matter what number we put in for n, 6 or 12 or -4, if we multiply that value times 1, it's going to be equal to n. So this is true for all values. Similarly, here's another one, 0 times n is equal to 0, or n divided by n is equal to 1. Are there any restrictions? Okay, so restrictions again are we ever dividing by 0? All right, we're looking for that, or are we doing the square root of some value that's negative? So those are the two ways that we can be looking for restrictions. And clearly in our last example there is a restriction. So in this last one we'd say n cannot be equal to 0. Right? Otherwise that is undefined. Okay, so now those are examples of identities. Identities can also involve trigonometry. So there are some trig functions that are identities, and I'm just going to click over to our formula sheet here, and you'll notice that in our formula sheet, this is from our previous chapter. This is coming up in a second, but you'll notice that the definitions of tan and cotan and these reciprocal functions aren't there. So it's something that we're going to have memorized. But these ones here, which are coming up, not in today's lesson, but I think in tomorrow's lesson, you don't have to memorize. So you're going to see in our formula sheet, this left-hand column, all those ones are going to be, we're going to be doing this chapter. So it's kind of a nice thing that we don't have to memorize them. But the piece I'm going to give you right now, you should know. Okay, you should get memorized. So first of all are the reciprocal identities. So reciprocal has to do with 1 is equal to the 1 over something else. So if I define it like this, if I do the right-hand one, if I say, what about the reciprocal of sine? And I think you may remember it. The reciprocal ones, there's cosecant and secant, and one way that I often remember it is I say, oh, okay, if the one that starts with sine, the reciprocal of it won't start with s, it'll start with c. So this one is the cosecant, so I just go CSC, the cosecant theta. So again, we should remember these ones. The next one is the secant theta is equal to 1 over the cos of theta. And then the last one, probably the easiest one to remember, the cotan of theta is equal to 1 over the tan of theta. So commit those three to memory. Now there are also the quotient identities. So what is a quotient? Quotient is when the result of dividing. So what are we dividing? In this case, we can divide sine theta divided by cos theta. And what's that one? That's tan, isn't it? So tan of theta is equal to sine over cos. And the other one is cotan of theta is equal to cos theta over sine theta. Okay, so I'll just put a little asterisk by here, these ones, and that means know this, okay? Alright. Okay, so hey, I'm going to switch to blue now. Okay, so we can verify identities by substituting. So to verify, what does that mean? Verify means to show that the identity is true. Now it's not really a proof. So and you'll see why in a second. The first way to verify is substitution. So let's take the that tan theta is equal to the sine theta over cos theta. How could we verify that? Well, we could substitution, and what we can do is choose a value for, now our variable in this case, although it's not an x, it's a theta. Choose a value for theta, and this is our choice, and then see if it works, and test. Okay, so I don't know, we could pick, I don't have my calculator ready to go here, but let's say if we picked theta is equal to 1.9. Then we would see, we'd get our calculator going, and we'd say, okay, so the tan, we were wondering, what's the tan of, oh, sorry, what's the tan of not theta, but specifically the tan of 1.9. And we're going to test, is that really equal to the sine of 1.9 over the cos of 1.9? So when you plug 1.9 into your calculator, I think it comes out to something around negative 2.927, and of course it keeps on going. And when you do your calculator work and figure out what the sine of 1.9 is divided by the cos of 1.9, you do indeed get the same answer, 2.927. And it keeps on going. So it's not really a proof, is it? Because we just showed that it's true for one value. If we could test every single value out there and show that it was always true, then it would be a proof. Okay, so this is how you verify. This is what the word verify means, is you can substitute it in and test if it works for a particular value of your choice. The second one would be is by graphing. Okay, so similar to our previous explain question that you had on a test previously, here you can say, well, let's graph y equals the tan of theta, and let's graph y is equal to sine theta over cos theta. And how should they compare? Well, if they are indeed equal, they should look the same, right? So let's go over to, here we go, I got a Desmos all ready to go. Here is a tan of x, and you can, it's hopefully familiar by now. It does not draw the vertical asymptotes at pi over 2 and at 3 pi over 2 and all those multiples, unfortunately. So that's what the tan of x. Now if I draw the y is equal to sine of x over cos of x, you see how it changed colors, right? Because it went over top of it. So they're identical. They're right on top of each other. So yes, it works. Okay. So we can go over here and where's my OneNote? There we go. And we can show, yes, graphs are the same. Okay. Oh, graphs are the same. Okay. Looking at the bottom of this page, are there any restrictions on the reciprocal or quotient identities? In other words, are there any values of the variable for which the identity will hold true? Actually, should say will not hold true. Okay. So note any applicable restrictions beside each identity above. Well, so same idea. We want to say that this restriction here, where am I? There we go. This restriction here, the restriction would be that the sine of theta cannot be equal to 0, right? Cos of theta cannot be equal to 0 because they're undefined, right? Here, cos of theta can't be 0, and this one over here, the sine of theta cannot be equal to 0. So these are all the restrictions here. So that's they are still the case when you have the quotient and these trig identities, and you can identify them for where there would be a vertical asymptote if you were to graph them. And on our next page here, we're going to do some simplifying of expressions. At the bottom, or here we go, I should say, probably the number one strategy that I have when I'm going to be simplifying this is to reduce, I'm looking at this first one, to reduce things to just in terms of sine and cos. You can sort of think of those as the building blocks of the other functions. So if you put everything in terms of sine and cos, that's always a good step to try out first. So if we take tan, we're going to substitute in the identity for tan, which is the sine of theta over cos of theta, and multiplied by the cos of theta. Okay, so everything else that we've done thus far is leading up to do this, because this was our objective. It was to be able to simplify expressions using those reciprocal and quotient identities. So we took this one here, this is a quotient identity, tan is equal to sine over cos, and then we can say, hey, this looks just like we did before. If you want to, you can think of this as something cos over 1, so you got these two fractions, and if you have something in the denominator and something in the numerator, really what I'm doing right here is I'm dividing both the numerator and the denominator by cos, right? So my answer is going to be equal to the sine of theta. Would I have a restriction here? I just divided the top and the bottom by cos, so my restriction would be here that cos of theta cannot be equal to 0. Does that make sense? Alright, I don't think the question's asking me to find that restriction, but I'm going to put it in there anyway, so this would be my answer. Back to blue, this would be my answer, that the sine of theta. Okay, let's try part B here. Secant of x multiplied by the cotan of x times the cos of x, all divided by the cosecant of x. Well, let's try that first strategy, and let's change everything in terms of sine and cos. Okay, so first of all, secant is equal to 1 over cos. So I'll say 1 over the cos of x multiplied by, now cotan is equal to sine of x. Oh, no, I got that mixed up. Tan is sine over cos. So this one is going to be equal to the cos of x over the sine of x multiplied by the cos of x, all divided by, the cosecant is the same thing as 1 over the sine of x. Okay, so you see how that works. So this was secant turned into this 1 over cos part. I'm just going to play with the colors because it's kind of fun. The cotan turned into this cos over sine, and the cosecant, just to bring in more colors, it's practically a rainbow at this point. That's how the work was organized so far. So now, can I do any canceling out? Can I do any simplifying? Well, here, these two multiplied together. I've got a cos here multiplied by this cos, so that is going to simplify out. Okay, so in my very next statement here, I'm going to get, looking at just the numerator altogether, I've got this cos x, and I can think of this as over 1. Sometimes it's simpler to think of that. So I'm multiplying the numerators together, and then I get a cos of x. So I got this 1 times, this was 1 because it got cancelled out, times cos. So over here I have cos of x in my numerator, and 1 times the sine of x times 1 over the sine of x. So this was my my numerator is now cos of x over sine of x, and my denominator is still 1 over the sine of x. Okay, so now what do we do with this complex fraction? We're going to say that this is equal to the same thing. Instead of dividing, we're going to multiply by the reciprocal. So I'll get the cos of x over the sine of x multiplied by that reciprocal. So it's the sine of x. Oh, I went over the edge. The sine of x, I think I can make some more space here. I don't know. Let's see what it does for me here. Sine of x, yeah, it does. Over 1. Okay, so I took this denominator here. This denominator here. When I made it to the reciprocal, I got this. Okay, so that was the switcheroo, and we can do some crossing out, so this sine of x and that sine of x. So after all that work, here is our answer. I kind of like it when it comes out so clean like this. My answer is the cos of x. So there is my cool answer. Alright, did it. Let's go take a look at example number 2. In example number 2, I have 1 plus the tan of theta all over the cotan of theta plus 1, and I'm going to simplify that to a single trig function, and it looks like I in fact have 3 different methods here. So Sometimes for people that just say, I want to memorize a method, one method that always works, these are kind of like puzzles, and sometimes you'll try something out and you'll see if it works, and you do not have to know all three different ways to do it, but I think it's a great exercise for us to see more than one method to do this. So the first one is what I was talking about before, is change everything to sine and cos. So looking over here, I've got this tan piece, right? This tan is going to turn into sine over cos. So let's do that. So we'll start off, we'll say 1 plus, now instead of tan, I'll say the sine of, now I'm not doing x, I'm doing theta, so I got to be careful to do theta. The sine of theta over cos of theta. Okay, so that was this piece here. And now our next one is the cotan here. We're going to change that to make it cos over sine. So down here I'll say the cos of theta over the sine of theta plus 1. And I got to put that green because it's just too much fun. Here we go. Done. Okay, so I think some of you may be able to anticipate our steps now. We have a whole number and a fraction, and we need to add these two together. So this 1 is going to is the same thing as 1 over 1. What's the lowest common denominator between 1 and cos? It's going to be cos. So this 1 over 1 I'm going to change to cos over cos. So cos theta over cos theta. See how that happened? This 1 turned into that. I multiplied the top and the bottom by cos. Plus sine theta over cos theta. Okay, I may run out of space here, but I think we're going to be okay. Now this on the bottom, I think you can anticipate it's very, very similar here. This 1 is going to turn into sine over sine. So I'm going to get cos theta over sine theta plus sine theta over sine theta. Okay, so now my next step, I need to go a little bit lower here. Oh, here we go. So my next step, I will be doing, I'll be putting these together. So my numerator, under one numerator, is going to be cos, I'll write it over here, cos theta plus sine theta all over cos theta. Okay, so here, all this stuff here together, that big numerator turned into this. Okay, so that turned into that. I put it in under one denominator of just cos. So underneath, we're going to get cos theta plus sine theta all over sine theta. Okay, so our first step was to get it all in terms of sine and cos. Our second step was, okay, we had a whole number and a fraction to combine those together, and I'm thinking some of you are already seeing it, that we've got a complex fraction, so we're going to do that multiplied by the reciprocal business. Okay, so my next step is going to be equal to, and so I'm doing equals all along the way, like this is equal to that, is equal to that, everything's equal so far. I think in your notes they might be doing everything just vertical and doing drop down below, but I think I'm writing too big for that. So now when I'm multiplying by the reciprocal, I will write out cos theta, here's the numerator, cos theta plus sine theta all over cos theta multiplied by, now here comes the reciprocal, right? So hey, let's go with this. What does this highlight look like? Ooh, that's crazy. So this one now is going to, I'll write the reciprocal of that, and I will get sine theta all over cos theta plus sine theta. So this was what I did as reciprocal. Okay, so you saw how that turned into reciprocal. Okay, now this is kind of cool. So I have a cos theta plus sine theta. You know, in fact, I'll write this out just so it's not too confusing. So these are added together, which is being multiplied by the sine of theta. So watch your order of operations. It's kind of like a plus b is all being multiplied times c, right? So the it's not cos theta plus sine times sine, it's these two are together, okay? So I'll even write this out one more time. The cos theta plus sine theta all multiplied by sine theta. Now this is going to be all over. I'm going to write this, but I'm going to put the cos theta plus sine theta part first, just so that we can see that we are allowed to cancel those out. Okay, so now we can see, oh yes, this is great. I'm going to be dividing the numerator and the denominator by the same thing, cos theta plus sine theta. So when I divide the top and the bottom by that, that gets canceled out. And now we look like we're done, except we just got to make sure that we're doing the question properly. Like we got it all the way down to sine and cos, but what do we want? We want it to get to a single trig function. That's what we want at the end. So we're not quite at a single trig function. We are at sine over cos. So is there a single trig function that we could write instead of sine over cos? Well, you bet. There's one, and we have a name for it. It is tan of theta. Isn't that fun? Okay. Some of you out there are going, this is crazy, Mr. Speiser, and some of you is like, hey, it's neat. It really is like a puzzle that you work at, and sometimes you're gonna like, oh, like there's so many steps, it looks so crazy, but it really, like everything else, it really is practice. Okay, so let's look at another method that some might use, and that is to change it all to tan. I think before that I might have to do a little bit of erasing just to make some space here, so I'll go like that. Hopefully that's alright. So if we're going to change it all to tan, okay, so here we're going to have 1 plus the tan of theta, so we've already got that, that's good, all over. Now cotan is the same thing as 1 over tan, so we can say 1 over the tan of theta plus 1. Okay, good so far. Now this denominator here, if we're going to combine these two together, this 1 would be the same thing. I can think about changing this. If I'm going to be adding this together, I need a common denominator. So this 1 I can rewrite as tan theta over tan theta. So I'll just write the numerator first, 1 over tan theta, all over 1 over tan theta plus tan theta over tan theta. Okay, oh, I think I'm messing up by not leaving enough space. Okay, so I'll do one to the right now here, which is equal to. So do you see what this is going to look like in the denominator? I'm going to get a common tan theta. So again, I'll just write the numerator. We haven't done any work with the numerator yet. We're just rewriting it every time. The denominator here is going to be equal to 1 plus the tan of theta all over the tan of theta. We are now indeed ready for the, instead of dividing by the fraction, we're going to multiply by the reciprocal. So down over here I'll say 1 plus the tan of theta multiplied by, now I'll take that denominator and do the reciprocal of it. So it will be tan of theta all over 1 plus the tan of theta. And then you can see again, I have to be careful the way I write this, because this 1 plus tan is being multiplied. The whole thing's being multiplied. And I am allowed now to do this simplifying of 1 plus tan, divided both the numerator and the denominator divided by 1 plus tan theta. And I'm actually done, aren't I? This is just, I'll have to just claim my answer. It's tan theta, because everything else got simplified. So again, a bit more sophisticated, instead of not turning all the way down into sine and to cos, to maybe to recognize, to start thinking ahead and say, hey, this might just work if I got a tan theta and I have a cotan theta. So how about if I switch them both to tan, and turned out to be a very good way to do it. If I go on here to method number 3, this one is rated as very sneaky. to multiply the numerator and the denominator by the tan of theta. So maybe since I'm all the way down here, I have to rewrite. I'm starting off with 1 plus the tan of theta. I think the question was all divided by the cotan of theta plus 1. So what we're going to do here is we're going to say, okay, I'm going to multiply this by tan of theta over the tan of theta. And so what do we get? Well, I got to put some parentheses around here, so I'm careful with my multiplication. Well, let's just see what happens when we multiply. So we're going to get this tan times 1, so that would be the tan of theta. And then I would have this tan times tan, which is tan. Actually, you know what? I think I'm going to leave that numerator, so I'm going to write it out. I'll just, it's so sneaky that if I actually multiply it out, it's not what I want. You'll see in a second. I'll just rewrite the numerator like this, times the tan of theta, because the whole purpose for multiplying it out was what's going to happen actually in the denominator. So I'll erase this red mister there, and I will put it in the bottom. Now let's do the multiplication just in the denominator. So I will multiply tan times cotan, and then we'll also multiply tan times 1. So when I multiply the tan times cotan, those are reciprocals. Okay, tan times cotan is going to be equal to 1. Okay, so just to think about that, tan theta times the cotan of theta is equal to, so remember tan is equal to sine over cos, and cotan is equal to cos over sine, or or they're reciprocals, just to recognize that. So clearly that's going to be equal to 1. So tan times cotan is equal to 1. Tan times 1 is going to be equal to tan plus the tan of theta. And now you'll see why I really didn't want to multiply that numerator out, because I want to keep that as a nice 1 plus tan. So really sneaky. I like that, sneaky, but it works, doesn't it? Okay, so if you can see that method 3 in these questions, you are definitely a high flyer in terms of simplifying these things using the quotient and reciprocal identities. So let's see that is it, I think, for our work today. And you've got some homework that is actually in the sheet to work on. So if you take a look at the next page, oh, I do have an example 3. Okay, I'm gonna leave example 3 on this video, and maybe I'll make another one so you can get another refreshment.